Welcome back to Section 3, Earth's place in the solar system. How did the Earth get here? What the heck, man? Well, it's called the nebular theory. Watch that word, theory. Highest level of knowing in science. Testable, repeatable, never been proven false, widely accepted. This isn't just a guess. All right. So, the solar system, the sun and all the planets and everything else in here, it all coalesced out of a swirling cloud of interstellar dust and gas called a nebula, starting about 4.56 billion years ago. There you go. So not only is the Earth that old, but so is pretty much everything in the solar system is right around that same age, 4.56 billion years old. How old's Mars? 4.56 billion years old. How old is Jupiter? 4.56 billion years old. So, again, out in space, there's these clouds of dust. Each little piece of dust, no matter how small, has mass. Mass, if something has mass, it has an attractive gravitational force. So if I put two things out in outer space, away from any big planet, if they're made of stuff, if they have mass, they will attract one another. Gravity is an attractive force. Now, here on Earth, there's something with a lot of mass, the whole Earth itself, that always attracts everything to it. It's the biggest thing in the neighborhood. So whenever the biggest thing is around, it has the biggest attractive force. So in any case, out in space, you get this big cloud of dust. And there's still clouds of dust around the universe. Each little speck of dust kind of has its own mass, therefore attractive gravitational force. And all these pieces of dust start to clump together to form little bigger pieces of stuff. Bigger pieces of stuff come together to form bigger pieces of stuff. And before you know it, this nebula, this cloud of gas and dust is starting to coalesce and come together. As this material is starting to come together under the force of gravity, the attractive force of gravity, everything that force of gravity is getting stronger and stronger with more stuff being added to it. So more mass, more attractive, more gravitational force, squeezing everything together. So much force that down to the atomic level, atoms were smushed together, called fused. And as you start to fuse atoms together, that's the process of nuclear fusion, a lot of energy is released. So nuclear fusion, that's the same process as the current nuclear weapons, nuclear bombs are concerned. When you fuse material, a lot of energy is released. So it's that fusion process of that cloud of dust and gas called a nebula, as everything is kind of smushing together, that created the sun. That's our star, the sun. So the sun turned on via this fusion process as these atoms of material getting squished together. It's also, the nebular theory is great because it also explains why the inner planets are rocky, solid, and the outer planets are made mostly of ice and gas, large gaseous planets. So here's a little pictorial representation. So you get the nebula, the cloud of dust and gas, kind of coming together, and it also begins to swirl. Some fun physics properties. So this material is coming together and swirling, coming together more and more and more, and swirling more and more. So, when things start to spin around, if I were to start to spin this around, try to watch my head here. All right, see things kind of flatten out and kind of go around. Well, as that material starts to compress, then we've got nuclear fusion. The sun essentially turns on. You get this material spinning. Spinning around, spinning around, spinning around. Again, the contraction at the center kind of started to fuse atoms together, which created our star, the sun. But what also happened is that disk of material called an accretion disk, this disk of material that kind of was spread out because of everything spinning around, started to kind of segment itself out into these rings. These rings of material began to clump together on their own, which eventually created the planets. Fun stuff. Now, the question always is, well, how do you know? It's just a theory. Don't sound dumb. Don't use that word in an incorrect manner. Nebular theory, testable, repeatable, never been proven false. Where's our evidence? It's everywhere. You just got to look up. All right. Now, obviously, you need a very powerful telescope, but here are some images around the universe of this very same thing happening. We see clouds of gas and dust called nebulas. We see them starting to spin around to form these disks at the center that, something is beginning to form, a star. We start to see again the star in the middle, and then these rings in that accretional disk forming that will eventually form planets. You just see it. What's your proof? It's pictures. I got pictures. Here's a bunch of pictures. There it is. Ta-da! Easy peasy. So that's how our solar system formed. Cloud of gas and dust coming together into the gravitational force, spinning around, kind of coming together. Sun turns on via nuclear fusion. You get this disk around our newly formed star starting to segment out into these different rings. Those rings eventually become the planets as all that material clumps together. So that clumping together of material, that accumulation, is known as planetary accretion. So these are how the planets formed. So the outer portions of that nebula kind of are cooled into kind of a disk of debris. That random collisions formed clumps that eventually grew large enough to pull remaining debris through gravity, kind of forming these different rings. That material began to clump together, which resulted in planets that were round. And planets are round and stars are round. I should say spherical, due to gravity. Gravity works in all directions, so that's why planets are spherical. No, the Earth is not flat. No, nothing in the solar system is a flat disk. No solid object is like that. Because gravity kind of works, makes things spherical. The Earth is a sphere. So you get those segmented rings kind of clumping together, creating these spherical planets because of gravity. There were some stray material that was never drawn in by the planet. So there's a bunch of material in our solar system. Think asteroids and comets and that kind of stuff. A bunch of material that never necessarily was a planet, just never got sucked in during this process of accretion. So there's plenty of other random stuff floating around in our solar system besides our star and the planets. Speaking of, Earth is one of 8, yes, only 8 planets in orbit around the sun. Sorry, Pluto. Also in the solar system, it includes, as of current count, about 140 satellites. That's the actual name for moons. There's only one moon in the whole universe, and that's ours. It's because that's the name of it. It's the moon. Just like if I'm in a room, there's 100 people in there, but there's only one Professor Kovac, because that's me, that's my name. Well, in our solar system, we have a bunch of natural satellites. These are things that orbit around a planet, just like a telecommunications satellite. Those are artificial satellites, but natural satellites are objects that kind of revolve around planets. So our natural satellite, its name is the moon. All right. Anyway, I digress. So in our solar system, we also have probably more than 140 satellites, asteroids, comets, meteoroids, dwarf planets like Pluto, and some others. Can you name the planets in order? I'm just curious. Stop and think about it. I'll give you a hint. Mavemjasun. Don't worry, none of this will be on a test as far as naming the planets in order, but just curious if you can. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Mavemjasun. So, by the way, this picture is not to scale. No, we aren't this close to the sun. This is just to show you relative sizes of these different objects compared to one another. The sun is so large it doesn't even fit only just a small portion fits on the screen. Again, this is not to scale. This is not where the planets are. This is just to show you the size scale, not distance scale. But Mercury, Venus, Earth, and Mars are known as the terrestrial planets. They're small, but have a high density, solid. And then you have the Jovian planets, or the gas giants, Jupiter, Saturn, Uranus, and Neptune. They're large, but relatively low density, made mostly of ice and gas and those sorts of things. And then you have stuff like Pluto and Ceres, which are both dwarf planets. Ceres is in the asteroid belt between Mars and Jupiter. Pluto is way out there in the Kuiper belt. There's a number of reasons why Pluto is not a planet anymore. Look it up on your own. All right, but why are these planets small and rocky, but these planets large and gaseous? Well, it actually goes back to the nebular theory and this accretion disk. Think about stuff spinning around, being thrown around. Let's say I have two objects. I have, I'm just making something up. Let's say I have a pen, and let's say this is a bowling ball. It's me. But let's say this is a heavy bowling ball. If I were to throw each of these, which one's going to go further? If I had just a light pen or this super heavy bowling ball, what's going to go further in the air? Well, the pen. It's much lighter. I'm going to be able to throw it much further. The bowling ball, or my head, I won't be able to go as far. So think about that same idea. As stuff is swirling around, what's going to go further? What material is going to go further? Well, the stuff that's lighter. What material is not going to go so far? Well, the stuff that's heavier. Well, what's heavier? Gas or rock? See what I'm getting at? So this leads to the idea of why the inner planets are rocky. So they are. There's a few different reasons. One is temperature. The high temperature of the inner solar system early on was around 3,000 degrees Fahrenheit. Excuse me. That really evaporated away any lightweight elements like hydrogen and helium. These are the number 1 and 2 elements on the periodic table. If any of you have ever taken chemistry, then they're the lightest of elements. So that stuff is very light. So that inner temperature really cooked off the lighter stuff, and all that material kind of just went further out. These are gaseous elements. Hydrogen and helium are gases. And that really only left behind the heavier elements or heavier compounds that weren't necessarily cooked off. A seismic explosion. When the sun turned on, when that material compressed enough, nuclear fusion began. That's a thermonuclear bomb. So that's going to create a large explosion, a large seismic wave, radiating out through the solar system. So a massive, massive concussion wave from the proto-sun, the birth of the sun, from its initial ignition, may have blown again away that thick atmosphere of gas and dust around the kind of inner solar system and pushed all that gas and lighter material out. Just like something light and heavy. If a force was applied, which one's going to go further? The lighter stuff's going to go further. And then gravity itself. As that, and this kind of touches on what I was talking about previously, as the nebula is rotating and spins out particles, the lighter elements can be thrown out further from the center while the heavier elements do not travel as far. So the heavier chunks of rock were also, since they're heavier, they're more massive, they were pulled in closer to the sun because of the sun's gravity attracting mass. The heavier something is, the more force of gravity there is. So not only could they not get flung out as far, they're heavier, so the sun actually wants to pull it back more. So the less massive gases kind of stayed further out. There's a less attractive gravitational force between those lighter particles and the sun. So the lighter stuff got flung out and stayed out. The heavier stuff didn't travel as far and got pulled in even closer. So that's why the inner planets are rocky and the outer planets are more gaseous. There you go. Every once in a while you'll encounter something like this. These are just some few extra videos that show you how the inner solar system formed, a fun little song on the solar system to help you remember the names, and additional information why inner planets are rocky and the outer planets are gaseous. So make sure you're watching these. These are linked also in the PowerPoint document in Canvas. So we're going to pause right there. When we come back, now that we've created Earth, we'll start talking about Earth and its formation and what's going on inside the Earth. I will see you back here in just a minute.